All right, so this is now arc length formula in terms of y. So we have our f is continuous on a and b just like before, and you notice now we have x is equal to f of y, and y is between a and b. All I've done is switched all the x's and the y's. The whole point is it doesn't matter if we have our curve and we're using x values with dx for our curve to draw all of our tiny little lines, right? And we're using those values to plug them in. It works the same way as if we had it with a curve in terms of y. And so we were plugging in y values for each of those with a dy. Works exactly the same way. These would now be f of y functions, and these would be f of x. So this is now what we're doing. So we don't have to do anything different. Same exact thing. So we're going to be finding f prime of y this time, which is basically x prime. With dy, it's dx. Let's just write it that way so that we have it because we're used to the other way. Dx, dy. So we're taking the derivative with respect to y. All right, now we distribute to get our f first. Let me move this down so that I have room. There we go. So x is equal to 1/3 y to the 3/2 minus y to the 1/2. So that would be 1/2. 1/2 plus 1 is 3/2. And that's just y to the 1/2. And then 1/3 would not cancel for the first one, but it cancels for the second one. All right, now we take the derivative. So this is 1/3 times 3/2 y to the 1/2 minus 1/2 y to the negative 1/2. All right, which equals 1/2 y to the 1/2 minus 1/2 y to the negative 1/2. All right, so just like before, we move on to the next step. So once we find f prime of y, we're going to square it. So we're going to take and square that. So f prime of y squared would be 1/2 y to the 1/2. And the more you do the squaring, the quicker you're going to get at it. Like that. All right, so for the first one, we're going to, oops, forgot the square. We're going to get 1/2 times y to the 1/2. So that's 1/2 y to the 1/2 squared minus, because there's a minus there, and then we're going to get 2 of them together. So 1/2 y to the 1/2 times 1/2 y to the negative 1/2 plus 1/2 y to the negative 1/2 squared. Okay, so squaring this one would be 1/4 y. In the middle, we get 1/2. That cancels the 2, so we end up with, again, 1/2. But 1/2 minus 1/2 is 0. So these are canceling. Remember, that one's on top. That one's on the bottom. They're just going to cancel. And that 2 will cancel with that 2. So we end up with minus 1/2. Plus 1/4 y to the negative 1. Because 2 times negative 1/2 is negative 1. Okay, so we're done with the square. And now we move on to the 1 plus. And there are multiple ways of doing this. You could have said, I want to add these fractions together and make something else and then square them. It's going to work perfectly fine. So this is 1 plus 1/4 y minus 1/2 plus 1/4 y to the negative 1, which is equal to 1/4 y plus 1/2 plus 1/4 y to the negative 1. Now, we can rewrite these as a fraction and then factor it that way, but we can also just brute force it. We know we need to make this into a nice perfect square so that when we square root it, it works out perfectly, right? We have our nice trinomial. So we do the same thing we did before. We're just going to guess, and then we're going to check it. Okay, so the square root of 1/2, 1/4 is 1/2. And so all I have to do is go 1/2 times 1/2, that's 1/4. Now we need the y. And so all we're really doing is square rooting this. So square root of 1/4 y, and we're placing it here. So that would end up to be square root of y, like that. And then here would be the exact same thing. So we're going to square root that one. So square root of 1/4 y to the negative 1. So if you think about this, we can leave it as square root of y, but you already know that the square root of y is y to the half. So we can do the same exact thing here. This is just a -1. So we would end up with plus, because the middle term's positive, 1/2 again, y to the -1/2. And all you have to do is check this to make sure it's correct. So if we took 1/2, I'm going to erase this to the -1/2, and we squared it, right, you would end up with 1/4. We already did that, see, right over here. -1/2 is y to the -1. So it checks perfectly that that's what we want. And then now all I have to do is make sure that the middle matches. So this one times this one is this. This one times this one is this. So if we square the first, square the last, we get the first and the last. First and the last. And we already know the middle is what it is. We did this one already here, but it was with a minus, and it gave us a -1/2. You see it? So if we were to take this one and this one, multiply them together, and double them, we would end up with a +1/2. Long story short, it checks perfectly. So now we can square root of 1 plus f prime of y squared is equal to the square root of 1/2 y to the half plus 1/2 y to the -1/2 squared, and the square cancels the square root. So we get 1/2 y to the 1/2 plus 1/2 y to the -1/2. So it just takes a little practice. You know what you're going for. You know you're looking for that perfect square. So now we go integral from 1 to 9 of 1/2 y to the half plus 1/2 y to the -1/2 dy. All right, and then now we just need to integrate this. So we're going to get y to the 3/2, and then again we flip it and put the 1/2 there. And then we're going to get y to the 1/2, and we flip it, times the 1/2 that was already there, and then 9 and 1. All right, so this is 1/3 y to the 3/2 plus y to the 1/2, 9 and 1. Now we just plug in the 9. So 1/3, this is 9 to the 3/2, 9 to the 1/2, and then we're going to minus, and we do the 1. 1/3, 1 to the 3/2 plus 1 to the 1/2. All right, so this would give us 9 square root of 9 is 3. 3 to the power 3 is 81. Sorry, 3 to the power 3 is 27. 27 divided by 3 is 9, and then we add to it our 3. And then on the bottom, I'm going to distribute the negative now. We get -1/3. I'll just leave the bracket, plus 1. All right, so this becomes 12 minus, and that's 4/3. So now all we have to do is add those up and see what we get. And so we can do that all in one step. With our calculator, we just do 12 minus 4/3 with a math fraction, hit enter. And at the same time, we're going to plug in our integral and make sure it's correct. All right, so 12 minus 4/3, there's your decimal. We get a fraction of 32/3. Plugging it in the calculator the same way, it also says 32/3. So we know that we are correct. It doesn't want me to write the answer. At 32/3. So again, the whole point is it doesn't matter if it says x equals or y equals. You do have choices on what you want to pick as long as your interval is also from y as well. Just think about it this way. At the very end, when you saw what I plugged in the calculator, I used x. Can't we just switch the letters here and do it exactly the same way? They're just letters, right? One's with respect to x and the other x-axis, and the other is respect to the y-axis. So just think about switching the rectangular coordinate grid.